Imagine standing on a cliff edge. Behind you is everything you have ever known. The smell of rain on hot asphalt, the sound of birds at dawn, the embrace of a loved one, the simple, unconscious act of taking a deep breath without a machine attached to your face. In front of you is a void, a silence so profound it has a physical weight, a cold so biting it freezes carbon dioxide into snow. This is the red planet. This is Mars. For decades, science fiction has sold us a sanitized dream. We picture gleaming domes, hydroponic gardens filled with lush greenery, and shuttles zipping back and forth between Earth and our rusty neighbor like a cosmic subway system. We imagine that going to Mars is like the age of exploration, Columbus sailing to the Americas, where the journey is hard, but the return trip is always an option. But physics, biology, and economics are conspiring to tell us a much darker, much more grounded truth. The first generation of Martians, the pioneers who leave Earth in the 2030s or 2040s, will likely never see the blue marble again. They are not tourists. They are not explorers who return with tales of glory. They are the first true exiles of the human race. To understand why, we have to strip away the CGI fantasies and look at the brutal calculus of rocketry, the frailty of the human body, and the unforgiving nature of the Martian gravity well. If you are ready to face the reality of our interplanetary future, and you want to be part of the community asking the hard questions about our place in the cosmos, verify your subscription now. We are building an archive of the future, and we need you with us. Let's begin with the most obvious hurdle, the tyranny of the rocket equation. Konstantin Tsiolkovsky, the father of astronautics, realized over a century ago that space travel is a game of diminishing returns. To move mass, you need fuel, but fuel has mass. So, to move that fuel, you need more fuel. It is an exponential curse. Getting to Mars is hard. Getting back is exponentially harder. When a spacecraft leaves Earth, it utilizes massive infrastructure on the ground. Launch pads, fuel depots, mission control centers, and thousands of engineers. We launch with the rotation of the Earth to give us a speed boost. We burn millions of gallons of propellant just to escape Earth's gravity well. Now, imagine the return trip. The first colony will not have a Cape Canaveral. It will not have a fully staffed launch complex. It will be a collection of habitats, likely buried under regolith to protect against radiation. To return to Earth, a ship needs to refuel. But there are no gas stations on Mars. This brings us to the concept of ISRU, in situ resource utilization. The plan, championed by agencies like NASA and companies like SpaceX, is to manufacture methane fuel on Mars using the Sabatier reaction. You take carbon dioxide from the Martian atmosphere, mix it with hydrogen harvested from Martian water ice, and create methane and oxygen. It sounds elegant on paper. In practice, it is an industrial nightmare. To launch a vehicle capable of carrying humans back to Earth, something like a starship, you need thousands of tons of propellant. To generate that much fuel, you need massive solar arrays or nuclear reactors to power the chemical plants. You need mining equipment to dig up tons of ice. You need storage tanks that don't leak in sub-zero temperatures. And all of this machinery has to work perfectly, autonomously, for years in a dust-choked environment before the astronauts even think about pressing the launch button. If the fuel plant breaks, you are stranded. If the solar panels get covered in dust and efficiency drops by 10%, you are stranded. If the mining rover jams a wheel, you are stranded. The logistical chain required for a return trip is so complex, so fragile, that for the first few missions, it simply makes no sense to rely on it. The safest, most logical mission profile is to send supplies, send infrastructure, and send humans, but not the fuel to bring them back. The cost of the return ticket is essentially the sacrifice of the colony's viability, and every kilogram of fuel sent for a return trip is a kilogram of food, medicine, or scientific equipment that didn't get sent to keep the colonists alive. But let's assume we solve the fuel problem. Let's assume the rockets are ready. We then run into a much softer, squishier problem: the human body. We evolved for 1 g of gravity. We evolved for a thick atmosphere shielding us from cosmic rays. We evolved for a 24-hour day-night cycle regulated by the sun. Mars offers none of this. The journey alone takes 6 to 9 months. During that transit, astronauts are bombarded by galactic cosmic radiation. These are high-energy particles that tear through DNA like bullets through tissue paper. By the time they land, their lifetime cancer risk has already spiked. Then, they live in 38% of Earth's gravity. We know from our experience on the International Space Station that microgravity wreaks havoc on the body. Bones lose density, muscles atrophy, fluids shift upward, increasing pressure in the skull and damaging eyesight, a condition known as Spaceflight-Associated Neuroocular Syndrome, SANS. On Mars, this degradation will be slower than in 0G, but it will be relentless. Over 5, 10, or 15 years, a colonist's physiology will fundamentally change. Their heart will weaken because it doesn't have to pump as hard against gravity. Their bones will become brittle. If a colonist lives on Mars for a decade and then tries to return to Earth, the transition could be lethal. Upon re-entry, they would be subjected to high G-forces. Their weakened bones could snap. Their cardiovascular system, adapted to the gentle pull of Mars, might fail to pump blood effectively against the crushing weight of Earth's gravity. Returning to Earth wouldn't be a homecoming. It would be a physical torture session. They would be crushed by the very planet that gave them birth. For a long-term Martian resident, Earth becomes a high-gravity death trap. Physiologically, they will have become Martians. The door closes behind them, not because of politics, but because of biology. Now we must look at the psychological and sociological architecture of a one-way mission. In 2012, a non-profit organization called Mars One announced plans to establish a permanent human settlement on Mars. Their key stipulation: it was a one-way trip. The media called it a suicide mission. Critics called it a scam. But when they opened applications, over 200,000 people from around the world applied. And why? Because there is a subset of humanity that is driven by something stronger than the instinct for self-preservation. It is the instinct for legacy, the instinct for meaning. Historically, many colonization efforts were effectively one-way trips. When Polynesian wayfinders set out across the Pacific in canoes, they were often leaving their islands forever, searching for specks of land in an endless ocean. When the early settlers arrived in Jamestown or Plymouth, they knew there was no 747 to take them back to London if the harvest failed. They burned their ships, metaphorically and sometimes literally. A return ticket creates a psychological safety net that can actually be dangerous for a colony. Because if things get hard, and they will get incredibly hard, the temptation to abandon the project and go home becomes a cancer on the mission's resolve. Imagine a dust storm that lasts for 3 months. The solar panels are operating at 20% capacity. The greenhouse has a fungal infection. The water recycler is making a strange noise. Morale is low. If there is a ship sitting on the pad, fueled and ready to go, the colony will fracture. Factions will form between those who want to stay and those who want to flee. But if there is no ship, if there is no option B, the crew is forced to solve the problem. Total commitment is the only way to survive an environment as hostile as Mars. As the famous conqueror Hernán Cortés allegedly did upon arriving in the New World, you must scuttle the fleet. You must commit to the land. Let's zoom in on the economics, the cold hard cash that dictates the movement of the stars. Current estimates for a crewed mission to Mars vary wildly, ranging from $100 billion to $500 billion for a government-led program. Elon Musk estimates a ticket price eventually dropping to $100,000 or $500,000, but that relies on a fully mature, rapid reuse infrastructure that does not yet exist. For the first missions, the cost per kilogram is astronomical. Every piece of equipment sent to Mars is worth more than its weight in gold. From an investment standpoint, whether that investment comes from a government like the US or China, or a private entity like SpaceX, bringing people back is a terrible return on investment. Think about it. You spend billions of dollars training an astronaut. They are a geologist, an engineer, a botanist, and a doctor all rolled into one. They learn the systems. They adapt to the environment. They learn how to fix the specific quirks of the habitat. After 5 years, that astronaut is the most valuable asset on the planet. They possess institutional knowledge that cannot be taught in a simulator on Earth. They know the smell of the air filters when they need changing. They know exactly how the dust behaves in the hydroponics bay. To spend billions more just to bring that asset back to Earth, where they will retire and give speeches, is a waste of human capital. The colony needs elders. It needs veterans. It needs people who have survived the great dust storm of '38 to teach the new arrivals how to survive the next one. The first colony will operate on a logic of accumulation. We send mass to Mars, machines, seeds, people, and we keep it there. We build a snowball of civilization. Subtracting mass from that snowball to send it back to Earth defeats the purpose of growth. There is also a darker, more existential risk that mandates a one-way protocol: planetary protection. We are terrified of bringing Earth microbes to Mars and contaminating the search for life. But we should be equally terrified of bringing something back. If the first colonists discover life on Mars, microbial, fossilized, or dormant, we enter a biological minefield. If there is extant life in the Martian subsurface, bringing a crew back to Earth poses a non-zero risk of reverse contamination. We have no idea how Martian biology, if it exists, interacts with Earth biology. It could be harmless, or it could be a pathogen for which terrestrial life has no defense. The Andromeda strain scenario is not just science fiction. It is a legitimate concern for astrobiologists. Strict quarantine protocols would be required. But how do you quarantine a crew that has lived in the Martian environment for years? Their bodies are covered in Martian dust. Their lungs have breathed recycled Martian air. You cannot sterilize a human being. The safest biological protocol for Earth is to treat Mars as a closed system. What happens on Mars stays on Mars. The colonists become the guardians of that new biosphere, separated from the old one by a firewall of vacuum. So, what does life look like for these one-way travelers? It is not a death sentence. It is a life sentence, a life of purpose. They will live in lava tubes, vast underground caverns shielded from radiation. They will eat lab-grown meat and algae paste. They will never feel the wind on their skin or the sun on their face without a layer of polycarbonate in between. They will age faster. They will likely die of radiation-induced illnesses or accidents. The first death on Mars will be a historic moment. The first funeral, the first grave dug into the red soil. That grave will be the anchor. When we bury someone in a place, that place ceases to be a campsite and becomes a home. We don't abandon the places where our ancestors are buried. The first one-way ticket holders are not just going there to live, they are going there to die. And in dying, they claim the planet for humanity. They will become the founders. Their names will be memorized by school children 3 centuries from now, beyond the first 100. They will be the mythical figures of a new branch of human civilization. But they will also face a profound psychological isolation. Imagine looking at Earth through a telescope. It's just a bright blue star. You can't see the wars. You can't see the borders. You can't see the pollution. You just see the home you abandoned. There will be days of regret, days when the machinery breaks and the air smells stale and the darkness of the tunnels feels like a coffin. They will miss the chaotic, messy, vibrant biology of Earth. They will miss the rain, but they will also experience things no human has ever felt. The beauty of a blue sunset, the towering height of Olympus Mons, the camaraderie of a society where everyone's survival depends on everyone else. A society with no money, no crime, and just a shared struggle against the void. This brings us to the ultimate reason why the trip must be one way. It is the only way to ensure we actually become a multi-planetary species. If we keep coming back, we are just visitors. We are just camping. To become multi-planetary, we have to sever the umbilical cord. We have to create a civilization that can stand on its own, independent of Earth. A colony that relies on return tickets is a colony that is looking backward. A colony of exiles is a colony that is forced to look forward. Elon Musk has said he wants to die on Mars, just not on impact. This is more than a quip. It is a philosophy. It is the philosophy of the seed. A seed does not return to the flower that created it. It flies away, lands in new soil, and destroys itself to create something new. The first generation will be that seed. They will be consumed by Mars. They will give their bodies, their health, and their lives to terraform the first tiny patch of ground. They are the fertilizer for the future. It is a harsh reality. It is a brutal trade. You trade the comforts of Earth for the immortality of history. You trade your old age for a chance to be the Adam or Eve of a new world. As we stand on the precipice of this new era, we have to ask ourselves, who are these people? Who would sign that contract? Perhaps you are one of them. Perhaps deep down, you feel that pull. The pull of the unknown. The feeling that you were born too late to explore the Earth, but just in time to explore the stars. The one-way ticket is not a trap. It is a filter. It filters out the tourists. It filters out the faint of heart. And it leaves only the builders, the dreamers, the martyrs. Mars does not want our visitors. It wants our commitment. It demands a blood sacrifice. And when that first ship lifts off, watching the exhaust plume cut through the Florida sky, we will know that the people on board are already ghosts to us. They are walking into the pages of history, never to return. They are leaving the cradle, and the cradle will remain empty. What do you think? Is the sacrifice worth the glory? Would you take the ticket if it was offered to you today? Or is the price of leaving Earth too high? Let us know in the comments below. And if you want to continue exploring the dark, fascinating realities of our universe, make sure you are subscribed. We have so much more to show you. Until then, look up. The future is red.